Hi everyone, welcome to today's Safety and Health webcast, Lockout Best Practices and Highlights from the new ANSI Z244.1 standard, sponsored by Master Lock Safety Solutions. My name is Tom Music. I'm an associate editor with Safety and Health magazine, and I will be moderating today's session. Thank you for joining us. In a few minutes, we'll start the presentation, but first I want to go over some housekeeping items. The views of today's speaker and his organization are his own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. A mention of any commercial enterprise, product, or publication does not mean the Council or the magazine endorses those items. At the end of today's webcast, we will conduct a question and answer session. To ask a question, simply type it in the text box that is located in the lower left-hand corner of your screen, and then click on the button for Submit Question. Feel free to ask your question at any point during the presentation. You don't have to wait for the Q&A session to begin. We'll try to answer as many questions as possible, but because of the large number of today's participants, we might not get to every question. However, all unanswered questions will be forwarded along to today's speaker. For basic troubleshooting information, click the Help button, which is located on your screen. At the end of today's webcast, you will be asked to complete a brief evaluation survey. I can let you know more about that when the presentation is complete. This webcast is archived, so you can access it after today's live event. To view this webcast and all of our past webcasts, go to safetyandhealthmagazine.com/events. With that, let's go ahead and get started. Our speaker today is Todd Grover, Global Senior Manager, Applied Safety Solutions for Master Lock. He has more than 30 years of experience as a practicing safety professional and EHS manager and has earned his business degree in administrative management. He has an advanced safety certification through the National Safety Council and is an OSHA-authorized instructor for both the general industry and construction 10-hour and 30-hour courses. Todd has worked with control of hazardous energy, lockout tagout, since the inception of the OSHA 1910.147 standard. He is a participating member of the ANSI Z244.1 Committee on Control of Hazardous Energy, as well as a delegate to the U.S. PC 283 Committee, contributing to the upcoming ISO 45001 Global Standard for Occupational Health and Safety. Todd, whenever you're ready, go ahead and take it away.
Well, thank you, Tom, and it is always a pleasure to be able to talk to interested safety professionals about best practices. You know, the best thing, the ideas of a lot of people doing this, a regular part of their job, and it's a pleasure working with the ANSI committee members to put our ideas together and take the standards to a even more positive level that reflects really working well out there in the world. I'd like to go over the highlights with everybody for this hour discussion, and just really lay out a little bit of the groundwork about ANSI and what we've done, and then go into the content that we're offering as part of the updated Z244 standard. As you may well know, ANSI got started in the 1970s with information related to unexpected startup of machinery. It first published our standard in '82, and what it did is establish best practice methods that OSHA paid close attention to. They found at the time they were issuing their regulation, it wasn't quite enforceable enough in its current length. Nonetheless, they picked up about 85 to 90% of the content of the original ANSI standard. We've run with that since 1989 in enforcement, regulation, and compliance practices. Now, we have been progressively working on the ANSI standard. In this iteration with the 2014 update and the 2016. Throughout the years, there has been steady through the ANSI committee on lessons learned, new technology, and I think this latest release expected in the fall of the year is really going to be the most progressive and innovative offering of ideas to date. We began meeting in 2014 on this standard, and we just closed a public comment period on the standard and are ready to review those comments and get a final version out. More than 50 organizations participated. It represented a wide range of industries and trade associations, labor groups, and government. was part of our sessions and has been observing the process all along. There's so much to discuss. We can't possibly put everything into this discussion. We did offer public comment for a 45-day period that just closed this Monday. Those have been submitted. We will be dispositioning those in August. We will then meet as a committee to final updated standard in 2016. And that is the basis of what I'm talking to you about as far as our work to date. So what we're going to go through is high points of the new standard. You can see here items 5, 6, 7, and 8 have been highlighted. That's where I'm spending my most effort. I think that's where the greatest interest is going to be from the audience. And certainly I would encourage you to go ahead and look for that standard out and buy it through the ANSI and ASSE website, and you can get the full detail of the valuable information it is. So to start the conversation, I want to start off with foundation, and that is how the equipment is designed to be more friendly for people trying to isolate and secure sources. Major work revolved around talking about the responsibilities of manufacturers, integrators, and machine buyers to incorporate an easier ability to apply lockout to the machinery. It comes in two ways. Number one, to make more requirements for providing local isolation on the machinery that simply have to be hooked up to the power sources that are expected to come to the equipment. That will allow point of access rather than distant access, and will make it a much clearer process for applying lockout devices, tagout devices, or alternative methods. There's also heightened language compelling providers to document safety systems such as guarding systems, methods of lockout equipment, tasks to be conducted, and associated instructions as to how to isolate and secure the machinery during those specific tasks. This should reduce exposures during routine and repetitive servicing and maintenance activities, and really that the end user buying the machinery, because what it does is give instruction as to the end user right from the originator. This is how the machinery is designed to be operated, tasks that must be conducted, and how to safely complete those tasks with the isolation machinery. Design considerations also took into consideration the advancements in interlocked and control reliable circuitry, and there is great detail provided in the Z244 Section 5 standard on a cross-reference of different interlock categories, risk ratings, the ability to retrofit new technology into older machinery. We wanted to make it clear, however, when we were discussing this, that it is a requirement of power to be present that justifies the use of engineering technology such as locks or control reliable circuitry to allow that to protect the worker rather than isolation. If tasks do not require power to be present, lockout is the way the machine should be, regardless of the level of sophisticated presence sense equipment that would provide guarding protection. We do note that even with technology, there's limitations provided dependent on the number of workers involved, so that the risk assessments have got to take into consideration the work to be done, but how many people need to participate and provide for accountability for those workers. Now, we've noted that state-of-the-art machinery is often being sold with control reliable dual-channel circuitry, safety componentry, meeting the ANSI B11 standards. Category 3 or 4 interlock equipment is certainly available on modern machinery. It can be retrofitted existing machinery. The cost challenges can be significant, and so we're confident that Lockout is not going to be a replacement technology, because even with it in place, there will come time where Lockout will have to apply to this machinery, and the knowledge and the equipment and the experience necessary to do the job is going to remain a requirement addressed by the rest of the ANSI standards. We developed more information related to the energy control program. Rather than walk through this point by point, you can see by our bulleted list there's a lot of it being addressed. One of the things that I wanted to emphasize was assignment of responsibility in a more detailed format than sometimes we see in existing programs. And responsibilities are not simply authorized and an affected person. It would entail program administration, frontline management, auditing, working with contractors, and so on. And the better you define what the roles are and the expectation of those roles, the more successful programs tend to be. There's also a lot of discussion related to task identification and whether or not the jobs to be done on equipment require full lockout, partial lockout plus other protective methods, or purely alternative methods of energy control. So more detail associated with the work to be done and the people and their responsibility than in past issues. So we've got information coming up on this, and I will be discussing it as it comes up in order. Hazardous energy isolation is a foundation of this standard. We talk about being mandatory anytime we've got a handheld, lockout mandatory anytime a risk assessment has not been performed for a job. There should be no consideration of doing alternative procedures. Risks are, the exposures may be, and the controls that need to be used. Lockout is the default if that risk assessment is not completed. Provided good guidance on risk assessment, annex of the lockout standard. Lockout or tagout is the primary means of controlling equipment when power is not required. And going forward, we look at considering the hazardous energy sources and isolating devices required. Tagout is more greatly detailed in the new ANSI, talking about the information has to be provided, as well as secondary protective measures that should be factored into tagout in order to fully protect people to be equivalent to lockout. Unless tagout is augmented by additional protective methods, it is not equivalent to lockout, and it must be in order to be considered a replacement for it. We find tagout is preferred because tagout does not provide exclusive control to the point of a person controlling a key. Tagout is more susceptible to tampering, defeated more easily, and tags and their methods are more subject to damage by the environment or external contact. Lockout procedures are discussed in terms of user friendliness. How do we get the message across?
Hi, everyone. This is Tom from the National Safety Council from Safety and Health. It appears that we have a little bit of technical issues with Todd's audio, so we're going to get him back on the line. So please remain patient with us. Todd, are you there?
I am.
Okay, I'm
Yes,
sorry. We
can
had
you
a
hear
little
me?
bit of an audio. Yeah, we had a little bit of an audio interruption. So I will turn it back over to you. Are you on a headset, Todd?
No, I'm holding the phone in my hand.
A handheld. Okay. Okay. If we have additional audio issues, I'll let you know. But you sound
Okay.
loud and clear right now, so I apologize for the delay.
Okay.
All right. Thanks, Todd.
Sure. Apologies to the audience. I understand there have been some sound problems. We just did a background check, and we seem to be fully functional. So we are good to go. So procedure content, very important to emphasize, because a lot has been learned about the development of formats that really speak well to what the needs of the workers are. And there's good guidance in the ANSI standard of what that should contain. For instance, there is requirements and how to accomplish this in the standard related to how do we document new machinery acquisition? How do we document existing machinery and any correction of deficiencies found once energy control procedures are applied? As far as energy isolation device identification, each energy isolation device should be properly labeled, and we did have some concerns about generic labeling that is repeated throughout workplaces. And an example would be using the same E1 label on every machine to identify the primary and first lockout point. That is an example of redundancy without any specification of energy type or magnitude, what machine it directly refers to. So it's problematic to use generic simplistic type labeling. We did talk particularly about a warning sign or placard that would be placed as an additional method when an energy device can't be secured by lockout or tagout. We want to be marking this status as close as possible to the energy isolation device and additionally at any control panel influencing the machine. If a placarding method is used, a high degree of communication and a procedure to do so should be well laid out. So this is a thoughtful consideration that some industries brought to our attention as being necessary for their practices, and their arguments convinced us this has merit as an additional protective method to be used within the standard. Verified effective by testing. This was a very important discussion, as many times what we see in standards are an author of a written procedure, an approver of a written procedure, a reviewer of a written procedure, and a reviser of a written procedure. That documentation all is valuable, but did the procedure ever go out to the workplace and get applied in a manner that demonstrates the procedure speaks to the right order of isolation, and does it speak in a language or a level of language that the intended user can work with? Verified effective by testing says somebody went out the first time this procedure became available, and they applied that machine and made that judgment, and if it did not meet expectations at the end user level, it is then upgraded and improved until by testing, it is proven to be an effective procedure. A document control system is really important in this regard. It assures timeliness of testing, that the publishing and accessibility to procedures is dependable, and a new inclusion in the ANSI Z244 standard is a management of change program intended to preempt equipment being changed without notification and updating of procedures, training, and possible machine guarding or protective measures. So management of change is well detailed in the new ANSI standard. It's a simpler form than some of you may be familiar with in terms of process safety management, and forms are provided within the ANSI standard that are a good basis for you to decide how you may want to run a management of change process. This said, to jump ahead to auditing, with verified procedures proven to be working successfully, and with a management of change program to document any changes before they're allowed to be made, before that machine is released back to the workplace, the auditing process of checking through your procedures becomes much more streamlined because they are proven, they are documented if changed, and this allows a better desktop auditing function than what we currently see, which is searching from memory or maintenance records, whether anything suggests the machine has been changed. There is a lot of desktop procedure auditing going on right now. This is a much more solid and foundational method of assuring that changes are caught when they are made and the procedure updated and the training provided before people are released back to use the equipment. Hazardous energy isolation. Some of the details that we wanted to update was to provide for control interruption when we have got to re-energize and test machinery and so on. What are procedures that should be followed? What are lessons learned in order to be able to position and test equipment? And there is also information based on how to remove lockout, tagout devices through a user-directed process, and that is a coordinated effort between shift and contractors and maintenance personnel. Good detail there that can be very helpful, I think, to either reinforce good practices you have in place right now or suggest better methodologies. One area that we noted involved a lot of lockout accidents involved outside services being brought in or contractors. And so an expansion of how-to methodology talks about a notification process to exchange information on hazards that the contractors may be exposed to or hazards that the contractors may create in doing their work that exposes facility workers to potential dangers. There is attention paid to coordinating programs between contractors and host companies. This reflects a lot of recent OSHA issues related to joint responsibilities for accidents on site, and it really benefited from contributions from a lot of major corporations who have excellent contractor programs in place. It did not add to the complexity. It actually simplified by putting in standardized processes to exchange information and processes that include temporary personnel on the job site. And as you know, that's a big emphasis of OSHA. There are any number of accidents recently documented that show that temporary workers who did not receive proper initiation into the hazards of the work floor often got jobs that were at a minimum setting them up as affected personnel, and in some cases in situations where they should have been authorized to apply lockout and have not. There was just a recent case released in by OSHA yesterday in Ohio citing $3.4 million for an auto supplier, a component manufacturer, who failed to get temporary workers involved, and it resulted in the temporary agencies, 3 of them who provide workers to this company, being cited for lockout-related violations associated with not training their workers. The ANSI standard is trying to address this with suggestions as to how this can best be accomplished. We've also looked at group lockout practices, both in terms of simple and complex group lockout, and annexes I and J in the standard talk to the methodologies of different group lockout techniques, providing great detail on how some of the best corporations and process sites in America are coordinating group lockouts, whether that be based out of an operations station, a permit to work type system associated with group lockout, It provides guidance on satellite lock boxes and really a how-to guide as to the way to achieve accountability and communication in a complex lockout situation involving many workers and multiple energy isolation points. We also dug in and tried to describe better shift or personnel change activities, realistic to say, how do we properly exchange responsibility for isolation of machinery? We're trying to emphasize bringing down the practice of leaving locks behind on equipment that could later result in personal locks needing to be cut off in emergency removal type processes by addressing a transfer lock or maintenance lock type process that allows securement of machinery, not during personal exposure, which would require personal safety locks, but in transferring the ability to secure and remove securement from machinery over a period of time, allowing incoming workers to replace maintenance or transfer locks and replace them with their personal locks, then reestablish that the machinery is in zero energy condition before beginning their work. So good guidance on how this type of transfer system works is now incorporated into the ANSI standard. Alternative methods of control are a big part of the ANSI standard and one I'm going to wrap up our conversation on. I would say that alternative methods has taken the place of almost a third of the ANSI standard. And in our practice at Master Lock, it is a major question area that we are constantly working with our customers on, trying to understand what's legal, what's gone too far, what's insufficient, and what are the latest and greatest methods which we've tried to address within the new ANSI updated standard. Now, OSHA says, as a reminder, that routine and repetitive jobs integral to the use of equipment for production qualify for alternative methods as long as we get the same level of effective protection as lockout. ANSI looked at this carefully. We realized that in many cases, the limitation of production-related tasks makes it very difficult for companies to do many of the planned maintenance, testing, troubleshooting type processes where power must be present. And so we have not one-for-one supported the limitation of production-related tasks. Our position in the new ANSI standard is lockout shall be used unless it can be demonstrated that the alternative method will provide effective protection. It shall only be used after hazards have been assessed through risk assessment processes, and before alternative procedures are used, we need some steps to be followed in order to meet the guidelines provided by the Z244 standard. The first is a practicability study, also called a justification analysis. It is a hard and fast and concise look at whether or not there is justification for power to be necessary to do a specific task. If that practicability study comes back and acknowledges, yes, this is valid, we do a risk assessment and we determine what are the exposures to our people and what are our options in terms of controlling them that will provide the most effective protection as possible. And so part of the risk assessments, we'll take a look and consider what have we learned from industry best practices? What are well-tried components and proven methodology, well-tried designs? Have we looked at common causes of failure and factored that into our risk assessment? What is the exclusivity of control? We may come up with an alternative method, but does it protect each and every person involved in the task? Consider tamper resistance and other programs to support this alternative method. This sounds like a lot in a short amount of time. Not every one of these evaluations is always applicable to an alternative procedure, but information in each one of these areas is provided in the ANSI standard to give you a good idea of its applicability and its value in doing your risk assessment process. And what we try to do is not just put this into words, we try to relate industry-specific guidance. So many of the annexes in the back of the standard are industry-specific to plastics and to food manufacturing and to robotics and on and on. Many different specific alternative procedure guidances are provided annex by annex on an industry-specific basis. Now, the committee looked at this and debated long and hard. Lockout is not always the only solution. We look at hierarchy of control, talking about the elimination or engineered prevention of exposure to a hazard, and find that when it is proven and when it is demonstrated to be dependable, control reliable, that it is often a better solution, perhaps, than lockout. And when I say perhaps, I talk about the human factor. Lockout requires a person to take action, to take accurate action, and to take consistent action. Lockout may eliminate the problem, but only if it's applied correctly. Lockout is procedural, subject to proper training and validation that people are doing as they've been trained. Lockout requires consistent human performance on many different levels, including notifying affected personnel. There are many limitations depending on interlock protection or emergency stop switches. For instance, interlock protection and stop switches really controls the activation stimulus. It is not an isolation of the power source in many cases. There is no control of residual energy that may be stored within the machine. Often these devices are tested or defeated in order to do testing or troubleshooting. And so the question of reliability is there, both in terms of human tampering, defeating, and how well they hold up to harsh conditions or repetitive use. For instance, in e-stop, it's designed to stop a machine in an emergency. It has a specific cycle life, and if it's the on-off switch every single day, every single week of the year, there's a point at which the e-stop may fail at a point where its true intended purpose to stop the machine in a hurry is put to the test. So there are limitations certainly on depending on engineered controls, and there is great guidance on, again, the control reliable circuitry, dual channel, redundant safety sources to control not only signaling, but energy isolation points. For instance, the current high-tech guarding out there, when it is triggered, it opens disconnects. It dumps air pressure. It turns off hydraulic pumps and creates automatic draining of hydraulic pressure within the system. All these are excellent engineered solutions that can be considered when the risk assessment has been performed and the dependability of these control factors are taken into consideration. So we have given a greater emphasis to the latest generation of interlocked controls and control reliable circuitry. There was strong representation on the committee from manufacturers and suppliers of these devices. There was real notation taken of technical advancements and methodologies used in other countries of the world. And so we find that when a risk assessment fully considers the capability of protective systems alternative to lockout, that a good decision can be made whether or not you want to consider that in lieu of lockout when your practicability statement has said we must have power for this task. So let's be clear. This is a lockout standard, and we are not abdicating to saying a machine guarding standard can take the place of lockout. When considering the infeasibility or impracticability to apply lockout to production, maintenance, or servicing work, take a look at this task list. If the task is of short duration, if it is of minor exposure, minor requirement for effort or utilization of resources, if it's occurring frequently, and if it is the role of people who are keeping the machinery running, which sounds a lot like the production-related activity, but quickly you can step out of the production-related realm to preventive maintenance that keeps the machinery going. When it represents cyclical activities like preventive maintenance, and it creates minimal interruption, these are all indicators that alternative procedures may be valid and should be considered in whether or not we can do something very safely without compromising the person, or depending on lockout as the one-stop solution to doing a lot of this work. Now, these tasks exist even when optimal operating levels are taking place, and for all of these tasks, if you are not going to fully lock out the machinery, it is not enough to say, I created a procedure. That alternative procedure must be presented to the workers doing the job. We emphasize the training that's necessary and the validation that the training was understood through demonstration and periodic validation. So by no means are we stepping away from our commitment that lockout saves lives. We are trying to give more perspective, more judgment and decision-making tools as to whether or not alternative practices have value in a workplace. Because right now, what our experience has been, particularly at Masterlock and certainly in conversations with my ANSI colleagues, lockout is done on tasks that are evidently requiring it, but in many cases, lockout is not being done and there is no protection for workers. In many cases, there is not the thought going into the alternative procedures in many workplaces around the country, and we're hoping this guidance document stimulates better practice and some better communication of the methods that are being used consistently if lockout is not indicated as the only choice to get the job done. Being said, if there is a doubt, if you cannot fully define a task, lockout is your solution until possibly better engineering studies, upgrade to better guarding materials and so on, or methodologies is put in place. So the practicability analysis looks at the impacts of lockout on the job. It talks about minimizing exposure to the worker by lockout, and when it is proven that power must be present for a lockout for a assigned task to be performed, it allows you to consider potential alternative methods, and they come in all shapes and sizes. Risk assessments are provided as terms of guidance based on industry best practices in several different annexes, annexes L to V in that new standard. So there's many of them taking an industry-specific look at what people have done to evaluate risks within their specific job sites and functions. A risk assessment should include well-tried components and designs that have proven their potential, and that can be gleaned from industrial resources, advice from providers and integrators. It is not hard to find this kind of consistent demonstration of effectiveness, and so we find that to be realistic to incorporate into the risk assessment. Common cause failures are also detailed, how one or more contributing events can cause the failure of multiple safety features. And I think that is a valuable aspect to consider. It lays out details of how things can combine to defeat a safety system such as an interlock and allow an accident to take place. So that needs to be a factor in risk assessments. Fault tolerance. Evaluating for potential failures and then equating them with the associated risks and exposures and severity of exposures to workers. We look at exclusivity. How do we provide individual control, person by person, who may be participating in alternative methods? It is not enough to do an alternative method to protect one person if we know the job may require two or more. That loss of sight of who else may be involved in the job can result in the person originating the alternative method to remove the protections and expose people. So the number of people involved and how they each participate in that alternative method is crucial. We look at tamper or override resistance. How easy is it to defeat or bypass this interlock type protection? In older interlock protection, it's real easy. In fact, many machines have had it dismantled and it no longer protects the doors and the covers on the machine guarding to points of operation and power-driven areas. So there is no doubt that tampering and defeat of interlocks has been a problem plaguing us, and it factors right into why lockout procedures are so important, even if those devices are used to protect workers from the consequences of sudden startup. And the alternative method risk assessment also requires review by qualified personnel. We want multiple eyes on what decisions are made. It shouldn't be a unilateral decision by the guy doing the job or the gal responsible for safety. There should be a combination of what does operations say, what do the machine experts say, what does plant engineering have in terms of contributing to this risk assessment process. That being said, I've described an awful lot of activity. We think we've provided streamlined methodology for people to follow, so it is not impossible to get this kind of attention paid. And frankly, it takes some work if you're going to say to a person, lockout is not necessary, we've got a better method, it'll protect you fully. You want to know if you said this is going to protect you fully, that you are speaking the truth for each and every person involved in the task. Risk assessment. Routine and repetitive tasks are easy to identify. They occur all the time. It's a task-by-task method that develops a series of control measures. All tasks and activities should be considered, such as what is required to operate the machine, to make adjustments, to do tool changes, cleaning, troubleshooting, that kind of thing. We have seen task lists prepared, numbering a dozen different activities on one machine, each either indicating this task requires full lockout, this task requires partial lockout, or this task requires an alternative method, and here's what it is. All movement and potential related energy hazards, well beyond electrical. You know, the mechanical movement, the heat conditions, stored energy, motion, elevated parts that could move and associated with gravity, and human factors associated with each task should be considered. And again, the guidance is provided within the standard through the forms that we've provided, through the descriptive information in those industry-specific sections as to how that applies to different jobs that are being done. Bottom line is you should assess potential exposure of all people involved in the task, including those affected by the job, consider the nature, duration, and frequency of exposure, and then develop measures that will protect those in the line of fire, as well as those that may be within the area that could be affected by a sudden startup. Although a third of this standard has been devoted towards expanding the practice and understanding of alternative methods, we want to come back to this point. Be honest and conservative. If your alternative method is rationalizing an activity without coming up with the conclusion that we can properly control risk, it is absolutely clear the task cannot be done under power. The task requires lockout to be applied until further notice, which may be until we update machinery or guarding methods or a new measure of protecting people comes along. Don't scrimp just because the job is desired to be done under power. It is incumbent that we pay attention to protecting the people where the exposure occurs. Okay, so we've been through highlights of the ANSI standard. I believe that there's been some questions that have come in, and I'd like to be available to answer those. So Tom, if you have got anything that has been offered by the audience, I'd be very pleased to talk to them about their inquiries.
That's great. Well, great job, Todd. Thank you for the presentation. It was really insightful and very thorough. Before we start the Q&A, I just want to remind everyone that the evaluation survey we're asking you to complete should be appearing on your screen. Your input is important because it will help us improve future webcasts. If you do not see the evaluation on your screen, please turn off your pop-up blocker. You may also access the survey by clicking the survey button near the lower right part of your screen. And with all of that said, we can get to some questions. And Todd, I can let you know we have a lot of great ones. Just as a reminder to everyone, if we're not able to answer your question, they will be forwarded along to Todd. So Todd, I'll start off with our first question here, which is it an OSHA requirement to complete a formal observation form annually, or is it hands-on competency-based training which is satisfactory?
You know, Tom, that's a good question. And just the way it was laid out there, it talks a lot to the auditing process. So let me just talk to that, and I'll talk to it from the ANSI standpoint as well as the OSHA. What is critical is that there is an observation made, at least on an annual basis, of the performance of personnel to meet the expectations set by the lockout program and indirectly by the procedure that they are following at the time they're being assessed. Now, there certainly has been some understanding by OSHA that if it is infeasible to check all your employees, that as long as there is a well-documented strategy to check, if you have 1,000 authorized workers and it is not possible to get eyes on every single one of them, what is your plan and how do we take a group this year and a group next year and make sure we are covering everybody in the assessment process? That being said, the expectation is we observe people doing their work. Did they lock out properly? Did they follow the procedure? Did the procedure guide them in the proper application of lockout? Was there any problems associated with it? Was everybody associated with the lockout participating in the lockout if they were hands-on the equipment? Was notification provided to affected personnel? That functionality we find is the most valuable aspect of auditing lockout. Whenever possible, it should be done live in real lockout situations versus staged demonstrations by workers to their auditors that they can lock out a specific machine. So how do we make that happen in real life? How do we keep track of what is actually being locked out? So what first-hand real observations can be made is a practice in understanding service routines, the requirements for periodic maintenance, and then getting that information to the people doing the auditing so they have the best chance of being present. Now, another part of that question seemed to refer to lockout procedures and the methodology on an equipment-by-equipment basis. ANSI supports the idea that single energy source machinery does not require a written procedure, and so that would leave out significant numbers of simple machinery. Nonetheless, it needs to be locked out. So an audit could be conducted on that simple machinery in terms of a performance audit. When written auditing of procedures needs to take place, if you look at what has been established by OSHA over the years, they would like to see that on at least an annual basis, every lockout procedure that is in use be reviewed for accuracy and completeness and determined if any changes to the machine or equipment or process has taken place that should be then updated in the auditing outcome in terms of corrective action. Again, it can be very, very difficult to have hundreds, if not thousands, of procedures and get eyes on every single one, which is why we really considered in the ANSI standard verifying each one as it's written or at the time it's applied for the very first time, correcting it if necessary, and controlling your workplace just as you would control people expected to apply lockout. If machinery changes are going to be made either by maintenance, by contractors, by operations, they need to know that word has got to be passed along to safety so that the management change process can document the improvement, and now you can track changes to your procedures very clearly, very carefully. And if a procedure was verified effective by testing on June 30th, 2016, 1 year from this date, if nothing has changed on that procedure and no management of change has been indicated, that procedure could be very well evaluated as good to go. Apply that to 1,000 or 2,000 procedures, and you can see that we can have a very responsible way of accounting for lockout activity and being sure the procedures are accurate and informative. So,
well, thanks for that.
That's my response.
Thank you, Todd. Yeah, well, that's great. That's great. You know, we also received a couple of questions about OSHA's role in the standard. Was OSHA involved in the standard, and what does the agency make of the standard?
Okay. OSHA was a member of the committee. They were updated as to all comments, all outcomes, dispositions of comments. They were provided with each progressive draft of the standard. They have been in an observational mode. They have not said anything negative about the standard, and when I bring that up, I really refer to the more open use of alternative procedures as the main factor, nor have they said they endorse that. Clearly, OSHA regulation would prevail. Our thought process is that if a company has a well-designed safety program that documents their expected performance of their workers, if safe working conditions are created, no hazards are created to the worker as a result of well-designed alternative procedures, there is probably little reason to expect an accident is going to spur OSHA attention. There seems to be a real emphasis on OSHA to pay attention to people who are not doing anything or doing things insufficiently. So I cannot say that until OSHA fully sees the finished standard and has a chance to comment on it, will we know truly their acceptance of the standard as it is now being released. However, we have gotten acknowledgement that there will be a link on the OSHA website to the new ANSI standard with the common disclaimer that this is an excellent source of information but does not necessarily reflect OSHA compliance one for one. I forget the exact statement, but OSHA does a very good job of saying very credible information, but not the same as the OSHA regulation.
Thank you, Todd. We also have a question toward the latter part of your presentation. You were discussing risk assessment. We have a question that says, who is performing this risk assessment and what qualifications are required?
That's an excellent question. Risk assessments are performed by people with both the understanding of the process of risk assessment, with the experience of knowing that quality information is being evaluated, so that it is not simply, let's give a class and go out and do risk assessments. Let's do them under the guidance of somebody who has got the experience until that experience transfer takes place. It should also be done under the eyes of people who have explicit experience with the operations of the machinery being assessed. So we find that often risk assessment is multidisciplinary. We would expect that a safety professional would be involved in a risk assessment, perhaps along with the operator or the maintenance mechanic that is familiar with the task and the work to be done. There may be an objective set of eyes, such as a department management, plant engineering, that wants to either be physically involved in the process or at least review and comment on results. So in a perfect world, one very excellent and experienced risk assessor could theoretically do the job very effectively, but they would have to be objective, very well trained and prepared. It is usually performed best as an interdisciplinary team.
Thank you, Todd. And I think we have time for one last question. We've got a couple of minutes here. It has to do with energy isolation. And the
Yes.
questioner is wondering whether you can recommend more sources of knowledge on energy isolation. In particular, who are the experts on verifying that energy source has truly been reduced to, quote, zero energy?
That I have an answer for that question. It may not be exactly the one that they were looking for. The expert on determining if energy is been fully isolated is the person at risk who is doing the testing of the machine itself. Okay, this person is applying a procedure that they may have participated in or may have been provided to them, but each and every time that procedure is applied, the controls have got to be verified. If there are hazards that cannot be verified operationally, such as electrical circuit testing to prove zero voltage has been attained, there may be qualified people that have to participate in that. But the best person, the best resource to validate a successful isolation of a machine is the person at risk who's charged with testing that machine and demonstrating this procedure has worked. Procedures are open to mistakes being made. And so the greatest expert in the world that could come in and say, yes, this looks absolutely great to me, we're good to go. But if the person applying the procedure is distracted, makes a mistake, misses an isolation point, locks out the wrong breaker, when they go to the controls and they test and action still remains, they're the expert that found that and recognized we have not achieved a safe working condition, and they are the ones that need to not only correct it, but should communicate it that, hey, I made a mistake or I found something that we've never seen before. Let's get eyes on this that can make sure it never happens to somebody who maybe did not check as well as I did.
Well, thanks, Todd. I think that's a great answer. And once again, we're coming up on the end of the hour here. And I'm sorry we didn't get to all the questions, but they will all be sent along to Todd so he can review those and get back to you as able. Once again, just to everyone, I hope you do take the time to fill out the evaluation survey that was on your screen, and you can give us your feedback so we can improve future webcasts. And with that, that'll wrap up today's Safety and Health Magazine webcast. I would like to thank Todd, Master Lock, and all of you who listened in. Thank you very much, and have a great day. Hi, everyone. Welcome to today's Safety and Health webcast, Lockout Best Practices and Highlights from the new ANSI Z244.1 standard, sponsored by Master Lock Safety Solutions. My name is Tom Music. I'm an associate editor with Safety and Health Magazine, and I will be moderating today's session. Thank you for joining us. In a few minutes, we'll start the presentation, but first I want to go over some housekeeping items. The views of today's speaker